Suppose we wish to solve a system of linear equations using the calculator. There are many ways to do this, and here's one way that does not use any app. To demonstrate this technique, we shall begin with the example x plus y equal 3, and then y equal 2x minus 3. In order to use the technique I am about to propose, we shall require the equations in the system to be written in standard form before proceeding. Hence we have x plus y equal 3 and 2x minus y equal 3. Now I shall enter in the coefficients in the order they are given into a matrix. And here's how you can do it without going into the matrix menu directly. You hit second and multiplication to bring up a square bracket. Now to enter in a matrix you have to do this twice. You need 2 opening square brackets. And then you can start entering in the coefficients. 1 for x, 1 for y, and then 3 for the right hand side of the equation. Close it with the square bracket by hitting second and minus, and then opening a new square bracket, no comma between, to have the next row in the matrix started. Then you enter in the 2, the negative 1 for y coefficient, and then 3 for the right hand side. Hit second and minus twice, second and minus, to close off the matrix completely. Now that we're done entering in these coefficients, I will store this as matrix A by going under the matrix menu and selecting A under names. So we'll hit the store button and then second and reciprocal key to bring up the matrix A. And now the matrix is stored. We're going to activate the rref command under the matrix math menu. And to get to this menu, we find the matrix option on your calculator. Now for a TI-83 Plus or a TI-84, it's located again under hitting second and the reciprocal key. But for standard TI-83s, it has its own button, and this button is located next to the math button. So we'll go ahead and go under there by hitting second and reciprocal, call up the matrix A, call up the rref command. Reduced row echelon form is what that stands for. And now we'll go ahead and call the matrix by name. And we cannot type in a square bracket, an A, and then another square bracket, because the calculator reads matrix names as one character, but we would type in 3, so it wouldn't come up right. So you literally have to go back under the matrix menu and select A under names. So we'll go under the matrix, call up names, and select A. And we'll close off this command and hit enter. Now, what the calculator has produced for us is the following interpretation for the results. 1x, right here, 1x, 0y equals 2. So x equals 2. 0x's plus 1y is equal to 1. So y equals 1. And there's the solution to our system, 2, 1. The reason for standard form is that it organizes the variables into columns. So it's very easy to pick out the coordinates for the solution. So let's look at another example. Here we have x plus 3y equal to 9, and negative 2x minus 6y is equal to negative 18. Now this time we will not store the matrix in matrix A, but we will move directly toward a solution by calling up the rref command under matrix math. So we'll go under the matrix menu, the math menu, and we'll go to rref right here. Call up that command, and then we will enter in this matrix directly with 2 opening square brackets. And then we'll enter in the coefficients. We have 1, comma, then 3 for the coefficient of y, and then 9 for the right hand side. Then we'll close this row with a closing square bracket. We'll open up a new row with an opening square bracket. And then we'll type in those coefficients, -2, comma, then -6, and then comma, and then -18. And after this, we will close this matrix by typing in 2 closing square brackets. And then we will close the rref command with a parenthesis, and we'll hit enter. Now we have the following interpretation, just like before. We have 1x, 3y equal to 9, 0x's plus 0y's is equal to 0. When you see a row of zeros after you invoke the rref command, this implies that our system is dependent. The lines will coincide. And to report such solutions, we typically let one variable be free and establish a dependency by solving one equation in terms of this free variable. Now, because I already have 1x, I'm going to solve this first equation for x. I'm going to let x be dependent on the value of y, and I'm going to let y be the free variable. This is merely out of convenience. So x is equal to 9 minus 3y, and y is the free variable. Now let's look at one more example. Here we have 2x plus 3y equal to 7, and 6x plus 9y equal to 5. And again, we will proceed directly without storing the matrix under a name. So we go under matrix first, then just go over to math again, and then we find the rref command, activate it, and then we'll type in the matrix of coefficients, 2 opening square brackets, and then the coefficients, 2, comma, 3, comma, 7. Close that row with a square bracket, open a new row with a square bracket, and then entering the next row of coefficients, 6, comma, 9, comma, 5. And then we'll close this matrix with 2 closing square brackets, and then we'll close the command, and we'll hit enter. In interpreting these results, just like before, we have 1x plus 1.5y equal to 0, and then you have 0x's plus 0y's equal to 1. Well, 0 does not equal 1, so we have a false equation. When you see a situation like this, where you have a row of zeros except that very last entry is 1, we have an inconsistent system. That means that the lines, in this case the lines are parallel, but the system itself has no solution. And the advantage to using this kind of technique over graphing is that with graphing you kind of have to have a sense of where intersection points are. Here you do not need that. You simply enter in the coefficients and let the rref command do the work. It does require a little bit of interpretive skills, but with practice this can be done really quickly. And this is how you can solve systems of equations on TI calculators by using the rref command.